Alright, so we're talking about transformations of graphs. So we're going to say f of x can be any of those 10 parent functions. Really, f of x could be any function in the world. Okay, but for our purpose, we'll just focus on the 10 parent functions. And c is going to be some constant. What do I mean by some constant?
It stays the same.
It stays the same. It's a number. C can represent any number. All right, real number. Okay, but it's going to stay the same. It's going to be some value. All right. What would happen to the graph of the parent function? So whatever parent function we're talking about. What would happen to the graph of the parent function if I, instead of graphing the parent function f of x, I decided to graph f of x plus some constant? What's it going to do? Shift it up or down? You guys agree? Disagree?
So wait, by parent function you mean the 10 functions we just learned?
Any of those 10 functions, yep. Let's say f of x, if you want to think of an easy one, x squared, think of the parabola, okay? So let's, if being abstract is tough for you guys right now, we're kind of going to say that f of x, if you want something specific to think about, f of x is going to be x squared, all right? So for those of you that can think about all the graphs in general at once, great. For those of you that want to focus in on one, let's focus in on just what x squared would look like, okay? Fine either way. C is going to be some constant. So the question was, what would happen to x squared, or what would happen to the parent function, if I took that function and added some c value after the fact? And Derek says it would shift it up or down. Thoughts? So in other words, what if I put a plus 4 back there behind the x squared? What would that do to x squared?
It'd shift up the y-intercept.
It would take the parabola and do what with it? Move the whole thing up 4 units. What if the constant was minus 3? So what if I had x squared and then a minus 3 afterwards? Take that exact parabola and move it down 3 units? Yes? No? You guys agree with that? Did you guys kind of find that a little bit in the worksheet? Okay? Anybody? Questions? Speak up. Okay? So you agree that if I add some number back here, whether that's a positive number or a negative number, that's going to take the parent function and just shift it vertically. Yes?
Yes.
Move it up or down. Okay? So f of x plus c shifts f of x vertically c units. That's kind of a fancy way or an all-encompassing way of saying it moves it up or down whatever the c value is. So if that makes more sense for you to write, say that when you add a number to the back end, when you say plus c back here, that's going to take the parent function and move it up or down whatever the c value is. If that makes more sense to you to write it that way, then write it that way. Okay? All right? What would that do to the parent function?
Left to right. Opposite.
That's going to move it horizontally. Okay? I'm going to go a little bit more specific on this one because I think it confuses a lot of people. Alright? But because it's a plus, I'm going to say that this would shift f of x to the left c units.
Isn't it
But, go ahead.
like, don't you set it equal to 0? Is that why it's?
That's going to be why, yeah. I'm going to talk about that here in a second. Okay. Where f of x minus c would shift it to the right C units. So far, so good on that? Okay. Y. Alright. Well, let's say we got this function here, f of x equals x squared. Okay, it's one of your parent functions, right? Okay, what's that graph look like?
Parabola.
Parabola, where's the vertex?
0.
0, 0. Okay? So the y-intercept is 0, 0, and the x-intercept is 0, 0. By the way, how do you find the x and y intercepts algebraically? What do you do?
Put a 0 in for x.
Put zeros in. Put a 0 in for x to find the y-intercept. Put a 0 in for y, then solve it for x to find the x-intercept. Okay? So, if I have this, okay, you guys know now what's that going to do to the parent function.
Shifts it to the left.
Shifts it to the left 4 units. But why? Okay? It is opposite, but the reason it's opposite is, well, or the way I can show you why it's going to be opposite is for you to just find the x and y intercepts. Okay? Or specifically the x-intercept. Alright? The x-intercept can be found by putting a 0 in for y. Okay? So I'd have 0 equals x plus 4 squared. Right?
Square root.
Square root both sides. The square root of 0 is still 0. The square root of something squared would just be that something, so x plus 4. Subtract 4. Negative 4 equals x, so negative 4 comma 0 would be your x-intercept. So this graph had an x-intercept at 0, 0. This graph has an x-intercept at negative 4, 0, so it moved it actually to the left 4 units. Okay? And then we could do the exact opposite if we saw x minus whatever. Okay? So that's kind of why it is opposite, because if you're finding the x-intercept, and I think this is a test question, why is it opposite? Okay, why is it opposite what you might think horizontally? Well, when you go to find the x-intercepts, and you're solving for x, that number gets moved to the other side of the equal sign, and when you move that number to the other side of the equal sign, it changes its sign. If it was positive and you move it over, it becomes negative. If it was negative, it becomes positive, and that's showing you why it switches from positive to negative, or negative to positive, or opposite what you would think. Okay? Okay. Austin, you're looking like you're going to ask a question.
Yeah. Is there an easier way we can describe that if we're asked it?
Talk about how you find the x-intercepts. And when you find the x-intercept, when you solve this for x, or show me each time. Maybe take a problem and show me if you can't explain it in words. Show me by finding the x-intercept. That would be my only suggestion if the explanation's not good enough. Okay? So, no calculators. You should be able to sketch this graph. What's the parent function? Square root of x, right? Okay. You're probably not going to do this, but maybe at first this is going to be helpful. Okay. I'm going to go ahead and draw a quick sketch of the parent function. I'll see 1, 1, 4, 2, so. There's my parent function, right? That would be y equals the square root of x. That would be our parent function. Okay? What does this plus 2 underneath the square root do to the parent function? Shifts it to the left 2. Okay? So it's like you're taking this red graph then right now, and you're shifting it to the left 2 units. So it would be right here, right? What's the minus 3 do?
Shifts it down.
Shifts it down 3. So if I wanted to draw a rough sketch of this, the biggest thing that I'm going to look for from you guys, because this is going to be a non-calculator portion on your test, okay? For a graph like this, do you have your starting point in the right spot, and then do you draw a generally good shape or the correct shape of the graph? Okay. The parent function we know starts at the origin. This moves it left 2, down 3. So as long as I see left 2, down 3, as long as I see that you're going to start your graph here and draw a pretty good shape, I'm going to be fine with it. Okay? Now, me personally, it bothers me to not have it fairly accurate. Okay? So because I know the parent function has a value of 1, 1, I'm probably going to make sure that I include that point right there. And then the parent function also has a value of 4, 2. So if this is my new point 1, 2, 3, 4, 2, I'm probably going to put a couple more points on there because I want to draw it pretty accurately. But that's not going to be anything that's going to be required of you. Some people like having it exactly right. Okay, I'm not going to check that. What I'm looking for is, do you start it right here, and are you drawing it correct in that sense? What questions do you guys have on that, so as far as your own grading purposes? I usually make a mental table of values sometimes too. I'm like, okay, I think this is right, but I'm going to check. So I'm going to plug in a -2 for x, and I better get -3 for y. You guys see what I'm doing here? I'm looking at what I think is the correct answer. I'm going to see if that coordinate works in this function. So because this coordinate right here is -2, -3, I'm going to make sure if I plug in a -2 for x, I get -3 for y. So -2. What's -2 plus 2? 0. Square root of 0? Still 0. -3? -3. Okay, that was good. I'll check one more just to be certain. This one right here is -1, 2. -2, sorry. -1, -2. -1 plus 2 is 1. The square root of 1 is still 1. -3 gives me a -2. All right, I feel pretty good about my graph now. I'm fine. I'll move on to the next problem. Okay, that's what I do when I do these, just to be certain that I'm graphing them correct and I don't have a calculator to graph it for me. Okay? So, thoughts on that? Okay? So, talked about shifting left, right, up and down so far. It's our left and right, opposite what you would think. This is vertically exactly whatever C is. Okay, yeah. If C was positive, you'll move it up. If C is negative, you'll move it down. Alright, what was next on our... We did up and down, we did left and right. I don't want my video to be forever long, so I'm going to make 2 of them.